Okay, in the second part of section 3.2, where we have some algebra applications. So we want to keep in mind the relationships that we have for these angles. When we have corresponding angles, they are equal to each other, right? Like angle 1 and angle 2, those are corresponding in that situation with the parallel lines P and Q. When we think about angles like this, 3 and 4, they're going to be supplementary because they're on the same side of that transversal. They're consecutive angles, so they're going to add up to 180. So alternate interior, alternate exterior, corresponding angles are all equal. And then our same side interior are going to be supplementary. So let's take a look at some of the applications that we might see here. So I can see right away, if I look at these two expressions here, 5y minus 5, or 5x minus 5, and 6y minus 4, they're going to add up to 180 degrees. Now, the problem with that is we have two variables in one equation. It's not going to be solvable. Okay? What I might like better here in this situation is to see that 5x minus 5, 4x plus 10 are corresponding angles. They're in the same position coming off of these two parallel lines. So I can start this with 5x minus 5 equals 4x plus 10. Okay? So solve that for x, and let's see what we get. We would subtract 4x from both sides. So I have x minus 5 equals 10, and I'm going to add 5 to both sides. Okay. Now we still have to solve for y, but we can come back up here and see the situation that we have. We know that these two angles right here add up to 180 degrees. So if x is 15, then I can take 5 times 15 minus 5, which would be 75 minus 5, or 70. So that angle there up top is 70, and then I can take that in with my other expression, 6y minus 4 plus 70 has to add to 180. Okay? So let's solve this for y, and then we'll have our two solutions. 6y plus 66 equals 180. So now I'll subtract 66 from both sides. 6y is 114, and then we just divide both sides by 6 to get y. So we have there y equals 19. So if we want to, in both of these situations, we have same side angles, so they're going to be supplementary. They're going to add to 180 degrees. If we want, we can just go right in alphabetical order, and we can start with x. So over here I have 10x plus 15x plus 30 is going to add to 180. Right? That would be my one equation. Over here, if we want, there's a couple ways we could think of doing this. These are definitely going to add to 180, but maybe you can see right away that if I just subtract 90 from both sides, these are actually going to be equal. If we have a 90-degree angle here, and they're same side supplementary, then it's got to be, this has to be 90 as well. It's got to be the supplement, since it has to add to 180. So we could, if we want, just start with 3y plus 18 actually happens to equal 90 anyway. Okay, so we could do it that way if we want. So we would subtract 18 from both sides. So I have 3y equals 72, and then we divide by 3. If y equals 24. Next, we'll combine like terms over here, coming back to this equation to solve for x. 25x plus 30 equals 180. Subtract 30 from both sides. So we have 25x equals 150, and then we would divide by 25. So we would say x equals 6 in that case. So two variables, two solutions. X equals 6, y equals 24. Okay, so now we have more parallel lines and variables to solve for again. So let's try to think about what would be a solvable situation here. When we look at x and 106, if we have the, let's start up here with these examples. I missed those for a second there. Let's look for situations that would allow us to solve for a variable, right? So I want to have x and x related to each other. So here in this situation, these are on the same side. They're consecutive interiors, so they're going to add up to 180 degrees. So 11x plus 4 plus 5x has to add to 180 degrees. Okay, and the same thing happens here. 5y plus 5 plus 13y minus 5 will add to 180 degrees. So now at this point it's just algebra solving. Keep track of our work here. So 11x and 5x would be 16x plus 4 puts us at 180. We subtract 4 from both sides. So 16x equals 176. I'll divide by 16, and that's a nice even 11 times that divides into that. Okay, we combine like terms here. We have 18y. The plus 5 minus 5 conveniently will go away. Right? They just subtract out. So 18y equals 180. We'll just divide by 18 and find that y is equal to 10. Okay. Now we come along here and look to see, do we have any angle relationships that we could solve for? Well, you might be tempted to think that these two here are supplementary, but they're not. This whole angle here and this whole angle, that's what would add to 180 degrees. So be careful there. Those two are not supplementary. But what we do have is a nice, easy alternate interior angle situation there, where 3x is definitely equal to 5x minus 20. Okay, so if we go ahead and solve that for x right away, that might be helpful to us. So I have negative 2x equals negative 20. So x is going to equal 10. Now let's see if we can work with that. If I know that x is 10, then I actually do know that I have 30 up here, right? This would be 3 times 10, which is 30. So now I have numbers that I can sum to 180. 30 plus that 2y plus the 4y. That will definitely add up to 180 degrees for us. Here we go. So we have 6y plus 30 equals 180. So we would subtract 30 from both sides. So 6y equals 150. And then we would divide by 6. So now y is 25. We went the other way that time. Okay, so now we can get back to, we were looking at this problem a little bit earlier. This x and this 106, they're going to add to 180 degrees. And then we go to solve from there. So if I just subtract 106 from 180, that would get me the value I want. So x is going to be 74 in that case. So if x is 74, let's take advantage of that. Notice that these are corresponding angles. So 2y equals 74, divide by 2, and we have y equals 37. And now I'm going to continue with that. Take this 74 and throw it up here. Those are vertical angles. So again, if we want to get z now, we take 4z plus 6 plus that 74. That ought to equal 180. So this is 4z plus 80 equals 180. And then we would subtract 80 from both sides. So we have 4z equals 100, and then divide by 4. So z is 25 in that case. And the last picture we have is very busy. There's a lot going on here. But the first thing I want to notice that I think I can take advantage of here is those three angles. They lie along a straight line, so that it's a linear, we could say linear pair, but they're supplementary. So if I add all this up, 2x and x, which would be 3x, plus the 90, that's going to add to 180. It has nothing to do with our parallel lines, just an easy grab for us to go and get x. So I subtract 90 from both sides. So I have 3x equals 90, and then very quickly and easily we get x is 30. Okay, that's the first one. Now let's see, how could we go about looking for what y and z are going to equal? Well, we do have alternate interior angles here. Here's our transversal, so I do know that 2y equals x, and I just found out that x is 30. So 2y equals 30, and we are now done with y. Okay. Furthermore, we have this straight line again. Right? We know 2y is 30, so if we want to plug 30 in here, and then observe that this 30 lives right alongside the z. So 30 plus z is 180. They're supplementary. That's a z. Okay, so we would subtract 30 from both sides, and z is just 150.